So today we're going to talk about discontinuities. Talked about domain last time. Discontinuities are things that could potentially impact the domain of our functions. We're going to talk about them. We have three types that we're going to consider. One of them is called a hole or a removable discontinuity, but we'll use hole. Vertical asymptotes. We've actually seen, again, horizontal asymptotes before. We talked about that at the very beginning of class. We saw horizontal asymptotes with our exponential functions last year in Algebra 1. We're going to see some vertical asymptotes today. And then something called a jump discontinuity. I want to talk about vertical asymptotes first, and then I want to talk about the difference between holes and jumps. So a vertical asymptote is this vertical line, well, they're called vertical asymptotes, that my graph can never touch or cross. At a vertical asymptote, our graph sort of splits, okay? It's going to go up forever or down forever. Maybe one side goes down forever. Maybe one side shoots up, right? Or comes down this way from up here. I could also see vertical asymptotes where my function goes up and then comes down. But the idea is my graph would be going up forever or down forever at that vertical asymptote. I have this split in my graph, okay? A hole is a place where, for a particular value of x, I am undefined. There is no y value. There is no point there. Okay? A hole means there is absolutely no value for y that you can give me. If I asked you to give me f of -2 here, you would tell me that it's undefined. We saw an example of this yesterday. This was an example problem from yesterday. At 3, right, we said f of 3 was undefined because I had an open circle and then another open circle. There is no y value when x is 3. That's a hole. If there is no y value, it's not an asymptote. We don't have a vertical asymptote there, but there is no defined value. That's a hole. Okay? A lot of times we have a little bit of a challenge to identify a hole versus a jump. For a jump, I've got usually something that looks piecewise, like a piecewise function. And at one sort of edge of my function, we've hit that boundary where we're transitioning from one piece of the function to the next. At one edge, I have an open circle, and then somewhere else, there's a vertical gap, but somewhere else, I do have a filled-in circle. This is a jump, okay? If I asked you what is f of -2, you can tell me what f of -2 is equal to. You would tell me that it's 0. You have a defined value there. We saw a jump yesterday as well with one of our examples. When x was -4, okay, on our line that we were traveling on, we didn't have a defined value there, but that point was defined somewhere else. That's going to be classified as a jump. If I have basically a point to fill in for that hole, we're going to call that a jump. So these are the three types of discontinuities we're going to see for today. We're going to practice identifying where we have discontinuities on our graph and then naming them. Is this an asymptote? Is it a hole? Is it a jump? And then we're also going to practice domain a little bit again. So for our first example, here's our graph. And I want to determine for all of these values of x, do I have a discontinuity? And if so, what kind? We'll name it. Or is that just a regular point on the graph? So here's my graph. Identify the type of discontinuity, if any, that occurs with each of these values. So when x is equal to -6, when x is -6, do I have a discontinuity here? Is there something weird that happens when x is -6? Yeah, I have a big gap in between where I'm coming from the left until where I would pick up at the right. I have this sort of vertical gap in there. That vertical gap is called a jump. This is a jump and not a hole because you can tell me what f of -6 is equal to, right? You have a point when x is -6. So that would make this a jump. How about when x is 0? Does anything weird happen when x is 0? No, my function, if I ignored all this other stuff, just a little curve right there. My function's just chugging along. No discontinuity there. And then how about when x is 5? Does something weird happen on the graph when x is 5? I'm like shooting up here, and then I'm abruptly coming down, but it's not connected. There's that space in between. That's a vertical asymptote. That makes sense why that's an asymptote? On the next page, we're going to see a new graph, and we're going to identify any more discontinuities. So here's our next graph. Identify any discontinuities. We're going to state the location, what the x value is, and then what type it is. Is it a hole? Is it a jump? Is it an asymptote? So as I'm looking at my graph, I can see something weird happens when x is -3. I have one of those sort of vertical splits in my graph. This end's going down forever. This end is coming from way above. Okay? So at x equals -3, we have a vertical asymptote. We have one of those sort of invisible lines that my graph can't cross. That is a vertical asymptote. And then after that asymptote, things are going fine until right here, until x is 4. At x equals 4, I have another discontinuity. What type would this be? This is a hole. It's not defined anywhere else. I don't have a point somewhere else when x is 4, so that makes this a hole. Let's do a little evaluating now. This is stuff we've been doing for a while. F of 1. So when x is 1, y is -3. So f of 1 equals -3. F of 9, when x is 9, we're right here. So y is -6. And then f of 4. When x is 4, what would I say? Undefined. Very good. Undefined. I don't have a y value when x is 4. It is undefined. So now if we bring domain back into the conversation, right? We talked about domain yesterday. We were to give the domain of this function in inequality notation. It's given here for us. So x is got to be greater than or equal to -9. So I have a filled in point at -9. And then at -3, we have this vertical asymptote, which means x cannot be -3. I've got to split up my domain interval there, my domain inequality there. Okay, can't be -3. At -3, right, I have to split this up, and then bigger than -3 up to 4. Can't be 4. X cannot be 4, so I've got to split up my domain there again. And then bigger than 4 up to and equal to +9. So there's our domain in inequality notation given for us. Let's change this into interval notation. So in interval notation, I'm going to see the same breaks, right? So we can go from -9 to -3. We can be equal to -9. So -9 will get a bracket. We cannot be equal to -3. So I want a parenthesis at -3. I'm going to do my little union sign. And our next piece of our domain is from -3 to 4. We cannot be equal to -3 or 4, so parentheses on both ends there. And then my union symbol. And the last piece is from 4 to 9. Again, we cannot be equal to 4. There's a hole at 4. But I can be equal to 9, so we put a bracket at 9. Again, make sure I can tell the difference between your parentheses and your brackets. Questions for me so far? Let's take a look at the next problem. So on the next page, same idea. We've got a new graph here, but same idea. Let's start by identifying any discontinuities for this graph. So where do I have something weird happening on this graph? -7, something weird happened. And it's well, it's going to be one or the other, right? And that's why I said earlier, it's kind of, sometimes it's hard to tell if it's a jump or a hole. So here's how we tell the difference. There is a gap here, right? A vertical gap. But do I have, like if I asked you, what is f of -7? Do I have a value that you can give me? So a hole, good. So at x equals -7, we have a hole. And I do want you to write x equals when you're identifying these values for me. It's important that we recognize these are x values that are giving us problems. And when I have an asymptote is a line, I need to write the equation of the line, which would be x equals whatever that value is. Anywhere else that gives us a problem? Anywhere else something strange happened? At -3, this one's a jump because you could actually tell me what f of -3 is. So at x equals -3, we have a jump. Now let's evaluate. When f is -9, when f is -9, what are we equal to? Oh, f of +9, sorry. +9, we're equal to 3. How about f of -7? Undefined, we don't have a point when x is -7. How about f of -3? F of -3, we do have a point there when y is 3. And then we've got a little composition here at the end. So remember, we're from the inside to the outside. So start with f of -5. F of -5 would be 4. And then we'll do f of 4. So f of 4 would give us 6. And then again, we have our domain given to us in inequality notation. So from -9 and including -9, we could be equal to -9 up to -7. So -9 up to -7. We have a hole at -7, so I cannot include -7 in the domain. I have to separate it. Okay. And then -7 up to +9 and including +9. So -7 up to 9. I want you to notice here, we did not split up the domain where I had this jump, right? I did not break up the domain at -3 because -3 has a defined value, okay? My function has a value at -3. I have a discontinuity there, but I don't have to kick -3 out of the domain like we do for -7, okay? So I don't have to break it up there. If I rewrite this in interval notation, I'm going to use the same numbers. I'm going to split at the same places. So this would be -9 to -7, parenthesis or bracket at -9. Bracket, we can be equal to -9. That's a bracket. How about at 7? Parenthesis, good. And then for my other piece, -7 up to 9. Parenthesis or bracket at -7. Parenthesis or bracket at 9. Bracket, we can be equal to 9. You have one more example on the next page. A new graph. Same idea. Give me those discontinuities, a couple of evaluating problems, and then give me the domain. Okay. So for your next graph, Same idea, but I want you guys to try this one, and then we'll check it together in a couple of minutes. Make sure you're giving me x equals and then the number when we have any of those discontinuities. We have to say the location. Say where they're at. Alrighty, let's take a look at our last example here. Where do I have discontinuities in this graph? Where's the weird stuff? When x is negative 5. What happens when x is negative 5? VA, yeah, vertical asymptote, yep. Where else do I have weird stuff? When x equals 0, we have a hole. And I heard somebody say at 4, at x equals 4, what happens? I have another vertical asymptote. Okay. Again, those asymptotes are lines. So I want you to give me x equals there. Okay? And I want you to give me x equals even for the holes and the jumps because it's an x value that we're identifying, that we're using to identify that location. Okay, let's evaluate f of negative 7. What is f of negative 7? Negative 4. How about f of 0? Sorry, you guys. Undefined. Yep, just hard to hear you over there. Undefined. How about f of 4? That's also undefined, right? F of 0 is a hole, so there's no point when x equals 0. F of 4, x equals 4 is an asymptote, so there's also no point when x equals 4. So this is another undefined. Good. And then a composition here, so we work from the inside out. F of negative 1 would be 1. And then how about f of 1? It would be 6. Good. Okay. And then the domain. This time you didn't have the domain already. I asked you to write the domain. Okay. So my smallest x value would be negative 9. Since I have a point at negative 9, it's a filled-in circle. That would be a bracket. And then we can go up to negative 5. We have an asymptote at negative 5, so I've got to stop. I cannot include -5 in the domain. So I can go up to -5. And then the next section of my domain would be values greater than -5, but parenthesis again, because I cannot have -5. That's an asymptote. And then we can go up to an x value of 0. At 0, we have a hole. So I can't have 0, but I can have anything between -5 and 0. And then I can have anything bigger than 0, not including 0, but bigger than 0, up until 4, because at 4, we have another asymptote. So I can go from 0 to 4, parentheses on both, because I cannot have 0 and I cannot have 4. So anything between 0 and 4 is okay. And then for my last piece, anything bigger than 4 up to 9. We have 4 pieces for our domain here. Anything bigger than 4 up to 9. And I can include 9. We can have 9. So 9 gets a bracket. Questions for me on the domain there? Got a lot of things to consider for that one. Okay, so discontinuities. We've got holes, we've got jumps, we've got vertical asymptotes that we'll look at. For tonight, no new homework. Please do check Skyward and see if you have anything that's missing. If you've got it done already, let me know.